flip video about empirical formulas. An empirical formula is a formula that shows the smallest whole number ratios of an atom. So it's not necessarily a true formula. Instead, what it does is it takes a formula that you know and it reduces it down to its basic whole number ratios. So what does this mean? Let's take a look at an example. So if I have an example of C6H12O6, this is a molecular formula because it's nonmetal, nonmetal, nonmetal. Molecular is nonmetals. And this is the real formula. We call molecular the real formula. What's the empirical formula? Well, an empirical formula would show the smallest whole number ratio of atoms. This is not the smallest whole number ratio of atoms. I actually can reduce this down. If I divide everything by a common multiple of 6, or common factor of 6, this could go down to, let's take a look, what's called the empirical formula. Divide 6 by 6, you get 1 atom. Divide 6 by 12, you get, well, that should say 2. You get 2. Divide 6 by 6 over here, and you get 1. Let's fix this up here. Put that 2 down there. Okay? So CH2O would be the lowest whole number ratio. Whenever you reduce down, that's called the empirical. Now, it would be nice if they gave us the molecular, and then we could do the empirical. It's a very quick math step. But the way we're going to see our problems are more like this. What is the empirical formula of an unknown compound that contains, what is the empirical formula of an unknown compound that contains 30.4% nitrogen and 69.6% oxygen? So we're going to start off with some percents. How do we get those percents? They probably got them from doing percent composition, which we've learned before. So we've got nitrogen in this compound and we have oxygen. But what does the formula look like? I don't know. I don't know the true formula, which is known as the molecular, and I don't know the empirical, which would be the reduced. So we just want to know the empirical formula, meaning the reduced formula. So to tackle these problems, there's a few steps. So these are important steps to have down in your notes. Okay, so let's take a look at these steps. Step 1. If you're given something in a percentage sign, you can erase the percentage sign and just put a G for grams. Okay, so again, let's just make sure you saw what we had here. We had 30.4% nitrogen and 96.9% oxygen. Okay, so I'm going to start off with those percentages. So step 1, 30.4%. I'm going to erase the percentage sign and put a G of nitrogen. And 69.6%, I'm going to erase the percent and put a G of oxygen. Notice, even though oxygen and nitrogen appear to be all alone, they are not diatomic. And the reason why is because the question asked us to find an empirical formula. A formula is when things come together. So we're trying to figure out when nitrogen and oxygen come together, what's their basic formula? Meaning they're not going to be alone. So no diatomic here, something important to write in your notes. Okay, I've done step number 1. What's step number 2? Very easy, something we've been doing in this chapter, and that is to take your gram values and convert them into moles. So let's do that now. I've got 30.4 grams of nitrogen, again not diatomic, times grams of nitrogen go on the bottom, this unit goes down here, and moles of nitrogen go on the top. Don't forget, 1 mole equals the molar mass in grams from the periodic table. So I pull out my periodic table, right? See here, I look up nitrogen on my sticker, and nitrogen is 14.01 in 1 mole. Okay? Do a little bit of math. So 30.4 divided by 14.01, and I get 1, 2, 3, sig figs, 2.17 of N. Okay, good. So far I've got moles of nitrogen. Now I'm going to go on and do the 69.6 grams of oxygen. Look up my grams of oxygen on my periodic table, and I know that that's 16.00 in 1 mole of oxygen. Type this into my calculator, 69.6 divided by 16, and I get 4.35, 3 sig figs, 4.35 moles of oxygen. Okay, so far I've done step 2. What's step 3? Step 3 says that I need to divide all mole values in number 2. So here are my mole values that I did in step 2. This was step 2. By the smallest mole answer. You should get whole numbers, you don't have to do sig figs here. Okay, so I look at these 2 mole values, and I want to divide both of these by the smaller one. Well, 2.17 is definitely smaller than 4.34. So what I want to do is I want to take both of these, and if I had 3 of them, I want to take all of them and look at all of them. You can have many. And divide by the smallest one. So again, I'm just going to transfer here. Step 3, I have 2.17 moles of N. That's the smallest. I'm going to divide both of them. So now I've got 1. And then I have 4.35 moles of O divided by, again, I picked 2.17 because 2.17 is the smallest. Let's go back and review that. This is the smaller of the 2. Divide them both by the smaller one. That's smaller, so I divide them both by the smaller one. Okay? And then when I'm done dividing this out, let's see what I get. 4.35 divided by 2.17. Good. And I get 2, and actually, to tell you the truth, I get 2.004608, okay? But if you remember over here in my steps, it says no sig figs here. So no sig figs, meaning I need whole numbers. Whole numbers. 1 is a whole number. And let's see, if I look next door, 2 has a 0 next door, so I can chop all this off, and 2 is a whole number. So I have 1 and 2. So far that's good. Step 3 is done. Let's go on to step 4. Okay? All right, let's see what step 4 says. Step 4 says the whole numbers, which are these, that I got in 3, okay, are the subscripts in your formula. So I have nitrogen and oxygen, don't forget, right? Nitrogen and oxygen, okay? So let's put them together in a formula, nitrogen and oxygen. And the question was, what are the subscripts down here going to be? That's what we're trying to figure out. And by doing all these steps, we got the subscripts. Here's the subscripts for nitrogen. Here's the subscript for oxygen. So instead of these question marks, we can fill it in as N1, remember the 1's invisible, O2. So maybe we can make a little arrow. These become the subscripts. How did I know N got the 1? Well, this was the one that I divided N, and this was the one that had the oxygen in it. Okay? Now, if you don't have whole numbers, what you want to do, let's say I got 1.0558 or 2.623, and it's not close enough to round, then I just have to multiply each of these by another number to get the whole number. Okay? Though we're not going to see an example like that today. Let's do one more problem, and let's use our steps. Here we go. We have 4.37 grams of P and 5.63 grams of oxygen. And the question is, what is the empirical formula? The first step we want to do, let's look at our steps, is to erase the percent sign and put G for grams. Well, there are no percent signs. I'm already set to go with G. So I can go on to number 2. It says convert grams to moles. Okay, so I start with 4.37 grams of P. Convert grams of P into moles of P. Okay, and I look at my periodic table, and I notice P is find P, 30.97 grams. And when I multiply and divide this out, I get 0.141 moles of P. Going to do the next one now, oxygen, 5.63 grams of oxygen. I know there's 16.00 grams of oxygen on the periodic table in 1 mole of oxygen. And when I divide these out, I get 0.352 moles of oxygen. Remember, it is not diatomic because it's going to be in a formula. P and O are going to be in a formula. What is their formula, right? P and O. So we're doing all these steps to figure out what are the subscripts. Moving on to step 3, divide all mole values in number 2 by the smallest mole answer. And I should get whole numbers. So which one's smaller, 0.141 or 0.352? Hopefully you said 0.141. So I take 0.141 moles of P, divide it by itself, and I get a whole number, 1. No sig figs on step number 3. See that in my notes? Okay. Then I do the next one. Just divide the page here. 0.352 moles of oxygen divided by, again, that small number. So I divide them both by the same one. And if you remember, no sig figs here, and I'm trying to get a whole number. So I take this, I do 0.352 divided by 0.141, and I get 2.5, okay? So now I'm kind of somewhere in the middle, all right? So what do I have to do at this point? So at this point, this is what I was talking about, is that if you're somewhere smack dab in the middle, you want to try to see what you can do to make this into whole numbers. So the way I'm going to do that is, what if I multiply this by 2 and this by 2? Do I get a whole number? Well, 1 times 2 is 2. I'm going to move this up here. And what if I do the same? Whatever I multiply this by, I should multiply this by. 2.5 times 2 gives me 5. Well, there you go. There are my whole numbers. And if 2 didn't work, I'd multiply them by 3. So start down with 2 first, and then multiply by 3 next if that doesn't work. So now I know that this is the P's, so P2, and this is the O5. P2, O5. Generally speaking, the one that they give you first in the formula usually comes first, and the one that they give you second usually comes second. Okay? Again, just to reinforce what we just said, I was given numbers. I got a whole number here, but I got a decimal number that wasn't easy to round. Okay? 2.5 is in the middle. It's not enough for me to say, yeah, that's 3. Okay? Maybe something like 2.99 would have been okay, but this is not enough. So I take basically a number and multiply them both by them. You have to do it by both to achieve a whole number. You start with 2, multiply them both by 2, and if 2 doesn't work, you go to 3, and if 3 doesn't work, you go to 4, and so on. So there's my final answer. That's how you do empirical formulas. That's the lowest possible ratio.